actually most of the job are done from Mr. Chen, but he's not here today, so I'm here and I present for him. This is the outline of this presentation. Firstly, I will introduce some research background of the digital photo marking. And then I will give briefly a description of the digital watermarking. And in this study, the digital watermarking is based on the point features. And the point feature is extracted by the same methods just mentioned in the previous presentation, the SIFT. So I will give you some the introduction of the SIFT algorithm, and then I will give you the detail of the digital watermarking based on the features from the SIFT. Then some experiment will show the results of the digital watermarking, and the conclusion and future works will be illustrated in the final. Because the development of the information and the communication technology, the people can obtain the digital data easy more than before. So you can get the many different kinds of spatial information via internet or via the digital medium. So the important issue is the copyright protection should be paid attention to, because some people may use the duplicate the image illegally, and some are not be expected for the producer of the image. So the digital watermarking is the solution for the copyright protection, and it is the process of embedding visible or invisible information into the digital signal images. And in this study, we are focused on the photogrammetry images. And actually, in the past, the digital watermarking technology has been successfully applied to the various kinds of digital data, for example, the music and the photos taken by the commercial digital camera. But it is rare to apply the digital watermarking in the spatial information. So this is our study issues. And for the digital watermarking for spatial data, there will be two important factors should be considered. One is the image quality conservation. That's if you put embedded some digital watermark into an image, the quality of the image should be decreases. So how to preserve the quality of the image will be important. And the other one is the robustness of digital watermark. That is, if you get the image and you have done some image processing, just like the rotation, the bring in and out, or the cuttings, then all the operations or the image impression will destroy the digital watermark. So how to preserve the quality of the digital mark will be the robustness of the digital watermark. And this picture shows an example of the visible watermark. It's a very simple method to put a trademark or a logo onto the image. But it will destroy the image and decrease the quality. If you want to extract the knife here, you will get no successful rate because of the visible digital mark. So our method will be based on the invisible digital watermark. The watermark will be embedded into the original image, and you will not feel any difference by visual. And we can also get the digital, retrieve the digital watermark from the images, and then to identify the watermark, you can know some properties of the digital watermarking for, just I say, the visual perception, the digital watermarking can be divided into visible and invisible. And for applications, the watermark should be robust. That is, they will, the digital watermark should not be destroyed after the feature image processing. And in this study, we are focused on the high robust. And then for the extraction methods, the extraction of the watermark can be bright or semi-bright or non-bright. The bright means that we can retrieve the digital watermark we don't need the original image. And in the non-bright, you need the raw image, the original image to compare and then to guess the digital mark. So our study will focus on the bright methods. And in the embedding methods, the embedding of the watermark can be based on the spatial domain or frequency domain or the vector domain. And in this study, we are focused the frequency domain. Actually, we use the Weber transform to hide the digital watermark. So the digital watermarking for photogrammetry, we should consider the feature processing by other users. They will include image measurement, feature extraction, image matching, or also image production. We should consider all the image processing, and all the processing should not, the processing cannot destroy the digital mark, and the digital watermark will be the robust. So we should consider the low distortion of the image. This will be preserve the quality of the image. And then we want to have a high robustness of the digital watermark. In our previous research, we have focused on this one, and we have get a very good result for the design of digital water for preserve the quality of the image. And in this study, we will develop a method to preserve the high robustness of the digital watermark. So the purpose will be to resist the damage of ozone image manufacture processing on the watermark. We hope that although the image are used to produce the ozone image, we can also find the digital watermark from the ozone images. And the algorithm of the watermark can be divided to generation. The first generation of the watermark algorithm means the demand says it cannot resist any attack. And the second generation of the watermark is based on the features. So the feature will be an important information that we will embed it and hide the watermark in these features. This is our issue of this paper. So the features used in this paper is often from the SIFT, the scale environment feature transformation. And the step of the SIFT algorithm include the scale space extreme detection, key points localizations, orientation assignment, and the key points description. And the information on the scale will be used to reduce the number of features obtained from the SIFT, because you will get large amounts of features when you're using the SIFT algorithm. And the key point localization will be guess the location of the point, and we also find the orientations of the features. This will be used to normalize the image, and will be used to resist the attack of the image rotation. That is, when we embed the watermark into the image, no matter you rotate the image, we can guess the water digital mark smoothly. So this is a simple description of the SIFT algorithm. Firstly, you use the Gaussian filtering to guess the DOG, the difference of Gaussian and the image period, and then you calculate the extrema in the scale space. Then the key points localization is we use the index named stability to determine the strength of the key point. So the strong key point will be preserved for important features. Finally, we calculate the gradient, the magnitude, and the orientations of the features. So the information of the features from the SIFT will be used for the selection of watermark embedding areas. In this paper, we want to research the image rotations. So we select a circular area surrounding the feature. So that when you rotate the image, the surrounding is still circular. So it will not be affected by the image rotations. And the issue of the selection is the radius of the circle. So we use the scale of the SIFT features to determine the radius of the selected circular area. And this is a result of the feature point from the SIFT algorithm. And the circle means the selection area. We will put the digital work into the area, into the circular area. But you can find there will be overlap between the two different feature points. So we also have a criteria to remove the overlap. So in this example, there are 20 points are found in this image. After the removal of the overlapping, there are only 8 points are reserved. And the 8 point, the circular area of this 8 points, we will put the watermarking within this area. So the step 1 of the watermark embedding is to decide the circular area, and then we rotate the image according to the gradient directions. This means the image normalized. And then we cut the center parts of the selected area because we don't want to affect the feature point, because the feature point may be the important measurement point in feature. Then we rearrange the image to a rectangle. That's because in the next step we will use the wavelet to decompose the image to a frequency domain. And this is a digital watermark. This means the National Taiwan University, and you can also hide some information, the number or other information here. So we hide the information in the band coefficient or wavelet coefficient, and this is the formula for the information hidden. The step 3 and the step 4 for watermarking embedding is we calculate the inverse wavelet transform when we have embedded the watermarking into the selected area. And then the select area are put back to the original images, and then this will be an image with the watermarking embedded. And the watermark iteration is the inverse operations. You just do the inverse operation, you can get the watermark. We want to evaluate the influence of the digital mark, so we have used some assessment criteria for digital watermarking. The first one is to verify the quality assessment of the images. We use the mean square error and the peak signal to noise ratios to compare the original image and the image with the watermark. And the bus assessment of digital watermark, we will calculate the normalized correlations coefficients to verify the difference between the digital watermark. So this is image quality assessment, and this is original image, and this is the image embedded with watermark. You cannot find any difference by visual. And the PSNR value of this image will be 42.1, and this will be a very good results for the image comparison. And for the watermark robust assessment, the normalized coefficient is 0 to 9. This is the original watermark, and this is the watermark retrieved from the images. And you can clearly find the National Taiwan University here. So the issues of this paper is to find an algorithm to resist some image processing, just like the compression, the brightness adjustment, the contrast adjustment, or smoothing, or rotation, translation, cutting of 50%, and ruling 2, and 75 reductions. And you can find the result is very good in addition to this one, smoothing. This is the main problem. We are also, we want to find another algorithm to conquer this problem of the smoothing. And this the results shows the watermark robust assessment with different image processing. You can find the better results of the image after the smoothing. And the rotation, translation, cutting, and runs. And we also find some point in points 2, 5, and 6. The attack are very serious. So this is still the problem we want to improve. So the water algorithm is especially required to be able to resist the geometric attack when someone takes the image to do some image processing. And the accuracy rate of extracted watermark at number 4 is 0.9, and this will be good result for the image robust. In features, the algorithm of embedding the watermark will be improved so that the photogrammetry image embedded with watermark will not only has a low distortion, but also has the ability to resistance during the manufacture process of also images. And this is all of my presentation. Thank you for your attention.
Thank you very much, Professor Hsu. Do I have any questions from the audience, please? Yes.
Zhu, Taiwan. You have shown us only one watermark. Is that a complicated watermark? Is it a simple watermark? Have you tried some other watermarks in order to see if your algorithm that is combining the SIFT and wavelet altogether really workable? This is the first part of the question. The second part is, if a hacker knows you work with SIFT and he's also a SIFT specialist, perhaps you can make your result a little bit mixed up. I don't know.
Okay, thanks, Professor Wu. The first question is actually the factor of the digital watermark is not the complexity of the context. Actually, the important is the size of the watermark. For example, this one. Because this one will have most influence of the area of the image to embed its watermark, and no matter the context. We still have tried another, just for example, just the number, or just the characteristic of the Chinese characteristic. And we found that it is not important factor for this research. And the second question, okay, actually, we can make some. Here. I didn't tell you how I transfer the circular image to rectangular image. And you can also put the random processing here. We will preserve the Yeah.
I'll take the chair's privilege of asking a question. You mentioned that it was scale invariant. What's the impact of image resampling? Is your watermark preserved if somebody just imports this into Photoshop, resamples the image and regenerates it?
The sample is another problem. We are doing something for that because the sample is the important processing during the also image production.
Any further questions? No, I'll ask another if I may. This is unlike a photograph of the Mona Lisa or something which a copyright is held by the Louvre. I mean, one of the features of photogrammetry is that imagery is ubiquitous, it's everywhere. And so what do you envision would be the trigger for somebody who thought that the image was in breach of copyright? And what mechanism would they then have to search for the watermark and find out whether it was in breach? So mostly you showed the digital globe watermark, and that's clear, it's visible. You look, you see it. But as soon as the watermark is invisible, in some sense, you've solved the problem for the user because they can reproduce the image, and unless the original holder of the image wanted to challenge that, there's a lot of imagery of tops of buildings. So I'm just curious how you use this in practice.
I think this. We also have considered the problem you mentioned because I think although this is the visible, the digital watermark is not only checked by visual. We can also calculate some numerical index to verify the robustness of the watermark, and then we will find some meaningful symbol or meaningful number here, and you can also find which you can hide many different information of the image into the digital watermark. That's just based on your applications or the virtual processing, and I don't think I answered your question.
We should remind one more, Leon.
Out of curiosity, maybe I did not follow too closely, but okay. Your watermark is not visible, right? Yeah. It's invisible. So even if you put it there, after some time, how do you know where you actually put your watermark? How do you know where to look for the watermark?
Okay. This is the water interaction on the images. Because we know the location and the algorithm to put the watermark. So we need so we know the locations to guess the. And the key terms will be the seed. Because we use the features from the seed to guess the location of the features, and this will be when you look at the images or do some processing notations, we can also, for example, there are only 8 points found in this image. No matter you do any processing, it's still the 8 point will be detected by our algorithm. And in each location we embedded the digital watermark. That is, if you only find 1 point, you can also retrieve the watermark. Because everyone we put the digital watermark in each of the points.
Okay, I think it's time to start your answer. Yeah. Okay. I think next paper is Professor Wells, and